Good morning. I'm going to discuss now a little bit about this Rotax carburetor socket mold. This making carburetor sockets mostly for Rotax, but some motorcycles, things like that. This is a mold that was designed with many removable parts that can be interchanged. These core pieces are fastened in, we'll see, with a flathead socket-headed cap screw here. You can these flat-headed screws are holding on just from here down to here. Then the base part, that's just an insert that can be changed if for some time I wanted to make some different mold or something. I do a lot of things just in case sometime I want to change something, I'd have a way to do it. So far I've never needed to, but if you ever needed to, you could. It's making, right now it's set up to make carburetor sockets for the Rotax 582 in this cavity and this cavity are doing that. And these two are making carburetor sockets for the Rotax 503, 447, and 377 engines. In the center, it makes one socket for the Rotax 912, and for that piece we need an insert. This is what the inserts are for the Rotax 912. Steel insert. It's been fully tumbled and blasted and painted, and it's placed in the mold thusly. This particular mold is a transfer mold. I have a key on the outside right here that helps you put it together. I usually keep the key facing towards me so that I can pick up a part like this to put in there and put it thusly on there. Like that. It's pretty easy to put on. The little holes that you see here, it's making 3 of those fuel tank grommets. Every time it opens and makes the 5 carburetor sockets, it's making these 6 fuel tank grommets at the same time. You don't get much money for them, but I had the empty space in the mold, so I put a cavity in there for doing that. I'm getting too many fuel tank grommets, so I may change this mold and actually make this into some sort of a vibration isolator or mount for a muffler or something like that. I could change these, modify them by boring them out, putting an insert in there or whatever. This particular top part of the mold has a couple of guide pins on here. These parts can also be removed and changed for different carburetors. This represents the core that cores out the part of the socket where the carburetor fits on. You'll see the little groove in there that prevents the carburetors from being thrown. It's a mechanical lock. When you put the hose clamp around the socket, you'll see your carburetor has a groove. This should look just like the end of your carburetor as far as where the groove location and everything is. There's not a whole lot of difference between the Bing 54 and the Bing 64, which is used on the 912. You'll see it's a little bit different though, a little bit different diameter and shape to it. And it's made, this mold is made in such a way that you could change things. I can change these pins here. They're held on with a flathead screw. If I wanted to make a different size hole through these little bushings, I could do. Also, the plate itself, you'll see there's a lot of flathead screws around the outside. This actual plate, which is where the rubber transfers in, I should show you the other side here so you see. This right here is where the rubber goes in this pocket and squirts through these little sprue holes to fill out your part. And I should put that over here, you can see a little better. You can see all the pins here. And these particular parts that represent the carburetor itself with the lock ring on there. It's a mechanical lock ring. And these pieces will come off. As you can see, there's screws in here to remove them. So you can take those off if you want. So far, I haven't ever had to replace this or take it off, but if I ever had an idea where I wanted to make something maybe a smaller diameter or something where I wanted these screws or screw holes in a different place, maybe for a different diameter or something, I could make a new plate here. This plate could be replaced and you could make totally different bunch of parts. So, and while I'm on that subject, I better explain these cavities here too. These have little socket set screws. They're just set screws is all they are. And you'll notice that those are just slightly intersecting where the aluminum cavity is in there. And that's just to hold it together while it's cold. You see, they won't fall out of there. They're in there good. They're not going to fall out. If you need to change these, and I do from time to time, but not very darn often, you take out these set screws, and it's just a hole. I drill a tap drill size hole real close to the cavity, as close as I can get it to be in tangent with the edge of the cavity. And then I run my tap in. When I tap the hole, it'll cut those threads are cut in this aluminum. Just the aluminum's getting threads cut in it. So the threads are what's locking it in there, so it can't go in and out. And of course, when the mold's running, the aluminum expands and it's going to stay in there. It's not going to come out anyway. So that's how that's held in there. These other screws that you see on the top right here, that's just for these little inserts that core out it's kind of a counter bore on the part for where the bolts that hold it down. That's what that's for. And if I want to make a different combination, say I get too many of the 503 sockets and I want to make more for the 582, I can put in another one of these cavities by removing this and put another cavity in there. Then I would be making 3 carburetor sockets for the 582 and only 1 for a 503. Or I might be making them for a Honda Goldwing. I have different cores I can put in here to make the early Honda Goldwings had a carburetor socket boot on it, which I make in sets. And everything's stamped and labeled, but that would screw on here. And the outside is the same as a 503, but the thing for the Goldwing has an eccentric, it's off-center core that fits in there. And this little eccentric will make the part to make it so it fits on a Goldwing. Because it just happened to be a part that was very close to a 503 socket. And people are saying, well, why doesn't that work? Well, it would work perfect if the center of it was designed for what they wanted. And it's easy to turn this core piece. Any machine shop can make that for you. So that's how I made this mold. So these molds all come apart. The other thing I wanted to tell you about is a little about when you put these together, the mold release. I have a spray here. I get this from McGlue tube, this 1711L. That stuff, if you shake it up and you spray it on these parts, that would help lubricate it. You do it only when it's hot, otherwise it kind of rusts up. They're all water-based, they got water in them, so they'd rust up the mold. So you spray them on when it's hot. And you put that on there like that and drop it down on there. It lubricates the outside of this. This stuff has Teflon in it, and the Teflon does lubricate things, but I don't think it's really good for releasing the particular type of rubber that I'm using. It doesn't seem to work as well as the other stuff, which I'll show you that here. Okay, this is Mac 860, also from McLube. That's what I put in a spray clean bottle. You spray it on there. This stuff I don't use very much because I only use it once in a while. But you'll notice if you see these pins, I think the camera will pick it up. There's a little bit of a white residue on there. And the white residue is really Teflon is what you're looking at, is Teflon on there. And it does give you a build-up. You can kind of feel it on there that there's a bunch of stuff on there. And what it is it's Teflon. but that lubricates these pins real well when they go in and out. So I'll spray it any place where I have pins. On pins like this, on these pins, maybe in this hole, you can spray down in the hole, and that makes it go together well. The other place I'll put it is on this little pusher plate here that pushes the rubber in. I'll spray it around the outside of this here, because it kind of lubricates. It'll lubricate it and it'll stay on there for a while. It's not, the Teflon, like I say, doesn't really keep the rubber from sticking as well as the 860 does. But this is a good lubricant on hinges or pins or something like that. And a lot of rubbers, this stuff works fine, but I found on the rubber that I use, this stuff gives it a little bit of a haze, a white tinge to the rubber. The part just doesn't look as nice as this other 860 stuff. It doesn't make anything on the part. You can't see anything on the part when you use that. Like I say, I spray them usually just once a day. Usually at the end of the day, when the mold's still hot, I spray on the lube so that all the water in it evaporates right away and it doesn't rust up your mold. Spray that on and then put it in the press and let it cool off in the press. Shut your heaters off. Let the whole works cool down overnight, and that kind of bakes this MAC stuff on. It kind of gets baked. The release agent will get baked on, and it'll stay that way. And usually it'll run the whole next day without having to put any more lube on it at all. You don't need any more release agent. You just, because once it's baked on, it'll stay. Now, if you try to spray on release agent in the morning, spray it on there, and then try to run the press right after you spray it on, you might make some bad parts, because I found out the McLube release agent can maybe move with the flow with the rubber and get mixed into it, and could give you a weak spot in the rubber. It don't often happen, but it could happen. So that's why I always spray it at the end of the day. That's when I spray it. And of course, this also has the hole for releasing with air, with a little spring steel washer here, that the air, I use the air hose and blow through here, and that makes this thing pop right up. You can pry it loose too, and for when I first made this mold, that was how I was running it for a long time. I just used pry bars on it to pry it loose. But then I got the idea, well, if that air works for other molds, I'll use it for this one too. And sure enough, it works. So you just put it on there, and you put your air hose on here like this, and then up the thing will come. It doesn't work, of course, when there's no rubber in it. When the rubber's in it, it works. But with no rubber, you got to just lift it off there. That's the only way you can get it off. Okay, that's pretty much it for that mold. Now, I thought I'd show you how I prepare a mold to run for the next day. In the evening when I'm done running the mold, I'll show you how I set the press. The first thing I do is I slide the mold all assembled into the press just like I would if it were hot. Turn on the safe switch, turn the power on. That work actuates the controls. And then I push the start button just like I was starting a cycle. And I run the press up. Now I don't leave the press sit there with full pressure on. I wait until this piece here just touches the bolster of the press. As soon as it touches, I shut it off. No reason to run it to full pressure. I just want it held in there to keep the platens in contact with the mold itself. And by turning off this safe switch, it makes the press stay wherever you put it. It's going to stay there. So I turn that off. That cuts off the power to all the solenoids. Now, with that off, it's going to stay there, and it'll stay there indefinitely. Now I can turn on these two heater buttons here. I set my temperature controllers for the temperature I want, which in this case is 320 on one, about 280 on the top, or no, the lower one's 320, the top one's 280 on the top, and the is 320. So I set those little dials to that. Then I set a timer on the wall that controls the plug, which works on regular 120 volt current. I just use a common ordinary timer to set it to turn on at 6 o'clock in the morning. So if I turn these heaters on, the press will stay there because this switch is off. The press will stay with these two switches on. At 6 o'clock, it'll start heating up. It'll turn on these two heaters and it'll heat the platens of the press and your mold. And you come down at 7:30, 8 o'clock, your mold's hot, ready to run. So that's all there is to setting the press. There's no more to it than that. And in the morning, it's ready to run.